Good afternoon, this is Teacher Patrick, and today we're going to look at Chapter 13, Waves, Cathode Ray Oscilloscope. Now, the cathode ray oscilloscope, guys, is a voltage output with frequency or time at the bottom, okay? So we can see here that we have our bottom divisions, okay? The louder my sound gets, okay, it measures any voltage, any vibration, or any sound. So if I increase my frequency of my sound or my vibration or even my alternating current, if we think of voltage, we'll have more waves per second. Okay, the gain of the oscilloscope helps us to find exactly the amplitude of this, but these waves are now not amplitude. Okay, the divisions that we're looking at, so what we use this is a time-based setting. Okay, so we can look at the different time-based settings. Okay, as soon as we can see that the amount of waves that fit in one time-based setting. Okay, so every time, every block is a second or a millisecond in this case. So one wave will take us 2 milliseconds. Okay, now if we get back to our formula or a definition for frequency, we will see the following. So the definition of frequency says 1 over the period, okay, or the time taken per wave. So a quick way to remember frequency is the waves, the amount of waves per second. Wave. So if I have 3 waves in 1 second, that's 3 hertz, 3 waves per second. The period is the inverse, it's the time per wave. Okay, so now we have the time per wave from my cathode ray oscilloscope. The time per wave was 2 milliseconds. Okay, so now I know that the period is 2 milliseconds, or 2 times 10 to the minus 3, and I can use this to calculate my frequency. So 1 over that will give me my frequency. As soon as I have my frequency, if I know the speed of a sound wave, for example, and I know its frequency, I can calculate the wavelength. So when we use a cathode ray oscilloscope, we look at we'll firstly look at the time-based setting. So from the CRO, we get our period. Okay, we use that to calculate our frequency. And from our frequency, we calculate our wavelength. Okay, it can also work in reverse. They give you the wavelength, you calculate the frequency, and then based on the frequency, you calculate what is the period for the CRO. Okay, now if we go back to our cathode ray oscilloscope, we will see here that the frequency might differ. Okay, so what you would do is you would try and find a point. So let's say, for example, we can't read exactly where the first wavelength is. You'll take the total amount of wavelengths that you can read to a defined point. Here I can see that the second wavelength is at a defined point. So it's 2 wavelengths in 3 time-based settings, so 3 milliseconds in this case, if we look at the seconds per division, and then from there we can calculate the period. Okay, but now it's 2 waves divided by so it's time per wave, 3 milliseconds for 2 waves, and we can get the period from there. So if you've got any further questions, please let me know. We're going to break down this into a few lessons, and we're going to look at it. Thank you and goodbye.